Good morning, class. We are looking at Module 5, practice test number 5, Module 5, which covers chapters 10, 11, and 12. Here's chapter 12, Analysis of Variance, or short, ANOVA. One-way analysis of variance, also known as a single factor, ANOVA, is used for tests of hypotheses that three or more populations have a means that are all equal, as in H0, mu1 equals mu2 equals mu sub 3, by analyzing sample variances. One-way analysis of variance is used with data categorized with one factor or treatment, so there is one characteristic used to separate the sample data into the different categories. The populations have the same variance, sigma squared, or standard deviation, sigma. So in short, when we have two of them, we use the t-test. When we have more than two, for example, 3, we use analysis of variance. In the F-test for analysis of variance, or ANOVA, two different estimates of the population variance are made. The first estimate is called the between group variance, and it involves finding the variance of the means. The second estimate, the within group variance, is made by computing the variance using all the data and is not affected by the difference in the means in the group. If there is no difference in the means, the between group variance will be approximately equal to the within group variance, and the F-test value will be close to 1. Do not reject the null hypothesis, mu1 equals mu2 equals mu3. If the means differ significantly, the between group variance will be much larger than the within group variance. The F-test will be significantly greater than 1. Reject the null hypothesis. That's the F-test. F is S1 squared over S2 squared. The ANOVA test is right-tailed because only large values of the test statistic cause us to reject equality of the population means. Other statistical tests, Chaffee test and the Tukey test, are used to find where the difference exists, although the t-test is commonly used to compare two means. It should not be used to compare 3 or more. 3 or more. Let's get this started with a simple example. Weights in kilograms of cypress trees were obtained from trees planted in a sandy and dry area. They were given different treatments as indicated. Fill up the table below and use a 0.05 significance level to test the claim that the 4 treatments or categories or factors yield cypress trees with the same mean weight. So the first group, there is no treatment. Or the category number 1. Second one, they get fertilizers. Third group, irrigation. Fourth group, both of them, fertilizer as well as irrigation. So what is involved in the calculation? We need to calculate n sub I, which means how many do we have here? In this case, for example, 1, 2, 3, 4, 5. So how many pieces? 5. They happen to be the same. They may not be. So n sub I, that means n sub 1 is 5, n sub 2 is also 5 all the way to n sub 4. N sub 1, n sub 2, n sub 3, n sub. The sum, the reason we use the sum is actually to find the average. So the summation of x sub I, add those numbers, put them here, add those numbers, put them here. So that this would be summation of x sub 1, this would be summation of x sub 2, and so forth. X sub I bar, then if you divide the sum by the count, you get this one. So this one is the second row divided by the first row. And the variance S sub I squared, again, I remind you, x bar for this one is summation of x divided by n. So this one divided by this one gives you the third one. And S sub I squared, we remember the formula for variance. S squared is summation of x minus x bar quantity squared over n minus 1. We do it with respect to each group separately for this one, for this one, for this one, for this. So those are the preliminary calculations. Again, for example, the first group, how many do we have? That's the count, n sub 1 equals 5. What is their sum? Add 0.24, 1.69, 1.23, 0.99, 1.8, you get 5.95. And what is x bar? X1 bar. If I divide 5.95 by 5, I get 1.19. And here's S1 squared using this formula. X minus x bar quantity squared over n minus 1, meaning 0.24 minus 1.19 squared plus 1.69 minus 1.919 squared plus this one minus this one is squared, and then divide by n minus 1, which means divided by 5 minus 1 over 4. Same thing for each group. So for each group, again, we have the count, we have the summation of x sub I, we have the average for each case, we have the variance for each case. Now, let's calculate the grand mean, GM, grand mean. Simply put, what is the mean for all of them? Never mind that we have 4 different groups, just for all the data. So 0.24 plus 1.69 plus this, all of these, add them up and divide by however many, which is 4 times 5, which is 20. So from 0.24 to 1.69 all the way to last 1.95 and divide by the total size of 20, and it gives us this answer. Now, we could calculate this since we already have this average. You can add this 4, divide by 1, 2, 3, 4. So note this grand mean, again, this is from the get-go. This grand mean, since we have this, we add them up, okay? Summation of x of I, okay, divided by 4. We can do that. 1.119, this one I meant. So add up the averages and divide by 4. This is a second way to do that. All right. So the grand mean is calculated to be this number. And we have a 1, 2, 3, 4 categories. K is 4, 4 minus 1 is 3, and n minus 1. N minus k is 20 minus 4. We're going to discuss that in a moment. Let's look at the SSB square sum in between. It's n sub I times x sub I bar minus x bar g m. So we are going to use for this one, for each group, n happen to be the same for each one. So 5 times, this is n sub I. So n sub 1 would be 5 times x sub I bar. That means x1 bar would be 1.19 minus x bar gm. That means 1.0935. And we square it. We do the same thing with the next one, and the next. So 5 times, if you look at the very first group, 5 times 1.19 minus 1.0935 squared plus, again, this happened to be 5. Again, 5 times x2 bar is 0.884 minus this number quantity squared. This one is 5 times x3 bar is 1.194 times the grand mean minus the grand mean quantity squared, and the last one, and ends up being 0.317295. So we got this one. We need to know again k minus 1, that represents the number of categories, 1, 2, 3, 4, minus 1, so that's 3. And then n minus k, we have total of 24 times 5 pieces of data, minus k minus 4 is 16. This is n minus k, because each one creates a n1 minus 1 degrees of freedom, and add them up to the next one and the next one. And so with that being the case, what is this? The mean square in between. You have to divide this one by k minus 1. So first of all, put those numbers 3 and 16. And by the way, this is the total. This is square sum in between, square sum within, square sum total, and this is degrees of freedom, 3, 16, add them up. And now this one, we have this number divide by 3. And when you divide this one by 3, gives you 0.105765, goes in here. The next one is calculating the sum of squares within, which means x sub I minus x bar a quantity squared. That means x1 minus x1 bar squared plus x2 minus x2 bar squared, and so forth. And if you want to calculate it in this manner, you can. Since we have that. So for, in this case, see, n sub I minus 1, that happened to be 5 minus 1 here, which is 4, times 0.39155, and I have rounded it, so I stopped at 5 and I rounded it to 6. 4 times that. This happened to be also the same, so 5 minus 1 makes it 4. This number again, just because the numbers are the same, times this one, again 4 times this one, 4 times this one, and add them up. So this is SSW. That means sum of squares within. And the total, just add these two. And to find this, you divide it by 16. So you divide this one by 16, right? That's why we wrote this. So SS within, divide by n minus k. And, or you can add this row. It's 1 squared plus S2 squared, and so forth, and divide by however many categories. It gives you the same answer. In other words, you're taking the average of that, and it gives you 0.27137. You put it here. So these are the preliminary calculations. Now, the way the F is calculated is the ratio of these two numbers. So F is MS in between over MS in within. So the ratio of these numbers gives us the F value of 0.3897. And as far as the degrees of freedom are concerned, the degrees of freedom for the numerator was 3, for the denominator is 16. So this is all the calculation with the details. So when you come across them, you can handle it. And now we are going to actually do the work. So we wanted to get this out of the way. Needless to say, it can be done by technology. So we continue with that. And this is the information we have. This is the information we came up with and we calculated from the previous page. Or if you run it through some sort of a technology, for example, Excel. And now let's write step 1, H0 and H1. H0 says mu1 equals mu2 equals mu3 equals mu sub 4, because we have 1, 2, 3, 4 categories for treatments, for factors, if you will, and that is the claim. On the other hand, H1, at least one of them is different. So at least one of the treatments has a population mean that is different from the others. And it's always right tail test. So we need the test statistic. And test statistic is this number. Again, it's generated by Excel. And I showed you how to do this by hand. So test statistic has a F value of 0.38971. Finding the critical value, first of all, this is the critical value. Secondly, if you were to find it from the table, number of groups factor, K is 4. Degrees of freedom of a numerator is K minus 1, 4 minus 1 over 3. Total size, 4 times 5 is 20, and minus the number of categories, 16. That would be the degrees of freedom of the denominator. And alpha is 0.05, and you can pick it up from the table. And of course, it doesn't have as many decimals as what we have here, but ultimately it's the same. So if we were to do the graph, we notice that the critical value of 3.289 with the alpha of 0.05, test statistic of 0.38971 is way into the non-rejection region. So we fail to reject H0. However, if we look at the p-value, we get, of course, the same result. Remember, alpha is 0.05. P-value is way larger than alpha of 0.05. Both of them refer to the same thing. Fail to reject H0. Okay, so if we are not rejecting H0, we are not rejecting the claim. The claim becomes true, and we just rewrite as follows. There is sufficient evidence to support the claim that 4 population means are all the same. We conclude that the 4 treatments do result in cypress trees with the same weight. In essence, doesn't have much of an effect whether you go with the fertilizer, irrigation, or both of them or not. That's the concept. Given the readability scores summarized in the following table and a significance level of alpha equals 0.05, use technology to test the claim that the 3 samples come from populations. It means that are not all the same from different writers, Clancy, Rowling, and Tolstoy. So first and foremost, they have the same n 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is 12. You need to calculate the x bar and s, okay? So n happened to be 12 for all of them. X bar, remember the formula, add them up, divide by size. S, we've discussed that, the square root of x minus x bar quantity squared, summation of that divided by n minus 1. So this comes from technology. So n, you can count it, x bar, add them up and divide, and s is calculated as follows. So if you go with Excel and run it, you get this result. and we're going to look at TI calculated result as well. But let's start. H0, there are three different groups. We are assuming mu1 equals mu2 equals mu3. And H1, at least one of them is not. We take it to be right tail test, and that is the claim. So at least one mean is different from the others because that's what we are checking. You follow what I'm saying? So that becomes the claim. And so the next one is the test statistic, and test statistic is given right here, F9.4695. The next one, we need the critical value. The critical value is given if you were to use just a table. Degrees of freedom of the numerator is 2, the denominator is 33. In other words, number of groups or factors is k equals 3. Degrees of freedom of numerator k minus 1, 3 minus 1, or 2. Total sample size is 36. Subtract the number of categories 3 and you get 33. And that's what we have here. And alpha 0.05, we have f equals 3.2849. We look at the graph, alpha is 0.05, and we throw in the numbers. The critical value of 3.2849 is here. And the test statistic is way larger than that, puts us way into the rejection region. So not only you reject it from here, you can reject it from the p-value as well. If you look at the p-value, it's way smaller than alpha of 0.05. By the way, if you go with the third one, you change this one to 1. That's why I'm showing you both, depending upon how you do the rounding. And needless to say, we have the same decision, reject H0. When you reject H0, that means you're fine with H1. You're not rejecting H1. You're not rejecting the claim. The claim becomes true. And then you go back to the question and rewrite. There is sufficient evidence to support the claim that the three population means are not all the same. We conclude that those books have readability levels that are not all the same. So we looked at the work by hand, we looked at Excel, and now let's look at TI. You go with one-way ANOVA, you clear list L1, L2, and in this case, 1, 2, 3, L3. If you have 4 categories, more. If you have 5 categories, more. So you need L1, L2, L3, L4, and so on and so forth. And stat test ANOVA. So you're going to put ANOVA, L1, L2, and so forth. So first, let's fill up L1, L2, L3. So 58.2, 73.4, and the rest of them, L2, 85.3, 84.3, and the rest of them. And then last one, 69.4, 64.2, and the rest of them. And then you simply put ANOVA, L1, L2, L3. That's all. And because there is an arrow, you go to the next one. And here's everything you get. Let's see what it gives us. Let's look at the numbers that they have given us versus exit so we can become clear as to what's happening. First and foremost, look at this number, which is the test statistic. Okay. And look at this number, which is the p-value. And on a normal basis for the test of hypothesis, those are the two main ones. Also, other calculations that are done here. If you look at this one, degrees of freedom was 2. Okay. Summation. Okay. The square sum was 1338.00222. And of course, we have it here. And the mean square is this number, which is this one divided by 2. If you divide this number by 2, you get this one. So they have done the calculation for us. If you look at this one, the same thing. Degrees of freedom is 33. Sum of squares is given. And you divide it by 33, you get 70. So everything that you need is here. Calculation by Excel, as well as calculation by TI.